Hi everyone, today we're going to continue our discussion on throttles. So this is homework number 8, problem 4 and part C. So this part C is actually very similar to part B. So instead of using 16 megapascal, in this case, because this operator didn't operate this throttle correctly, so in order to compensate this mistake, he reduced the outlet pressure of the throttle to 12 megapascal. So we were asked to solve for the phase, temperature, and density of the fluid at this condition. So first, let's look at what we have. So we know that at this point, P2, so instead of 16 megapascal, we have 12 megapascal. And H2 we already found from part B, it's 2652.8 kilojoule per kg. Okay, so in order to find the phase, we're going to do something very similar as what we did before. So we're going to compare the H with the H at vapor phase. So at this 12 megapascal, we can compare the Hg with this H2. So it turned out to be H2 is smaller than Hg. So instead of being superheated vapor, which is at 16 megapascal, this time it's going to be a liquid plus vapor phase. Okay, so this is the first part. And then the second part is to find the temperature. This one is actually very, very straightforward because right now, since it's a liquid and vapor phase, so it's inside of the vapor dome. So the temperature is equal to the Tsat, which is 597.83 K. Okay, and then the last part is to find the density. Remember density, okay, let me first circle this. So this is part of the answer. So remember density is also, so this is rho, density is also 1 over the volume. So if we're at state 2, which is rho 2 and V2, so then our goal is to find V. How do we want to find V? We actually need to use something related to quality, because if you look at this, right now, since we already said this is liquid and vapor, and we don't really know exactly which point this is at, so we're going to use different H values to solve for quality first and figure out which point on this line is our current condition. So let's get started with that. I'm going to change a different color. So H2 can be calculated from this equation, which is H2 minus H fluid. I always say this is fluid, so which is the liquid, and then Hg, which is a gas, so that's also that's the vapor, and then minus Hf. So this equation is universal when you want to solve for any type of properties in terms of quality. So this doesn't have to be H, it can be S, it can be volume, anything. So now we just need to plug in all these numbers. Minus 1491.5 over 2685.4 minus 1.5, and this will give us a quality of 0.9727. Okay, so that's telling us it's probably somewhere very close to this, so this is 1 and this is 0, so it's 0.97 something, so it's probably very close to the vapor phase. So now we're going to find out the volume, and that is going to be, let me change a different color again, so that is going to be, now we know the quality is going to be 1 minus the quality times the volume at liquid phase plus this quality times the volume at vapor phase. So if you just plug in all these numbers, 9727 times 0.0015263 plus 0.9727 0.14264. Let me rewrite the last part. This is not readable. Times, so this is 7, so these are 7s, times 0.014264. Okay? And this will give us 0.0139 meter cubed per kg. So this is the volume, and now if we want to know the density, we already said here it's just the inverse of the volume. So if we plug in 0.0139, and then we get our final value for density to be 71.859 kilogram per meter cubed. Okay. So this is the final answer. So part C is not too bad, right? Okay, so this concludes our problem number 4. Please let me know if you have any questions. Thank you.